You know that sound? That's what the radio waves that are constantly washing over our universe sound like when we turn them into audio. And yeah, most of it is just cosmic static, the background hiss of the universe. But every now and then, our telescopes pick up something different, a little whisper from the void that hints at a huge mystery. Our story kicks off on August 15th, 1977. At a radio telescope in Ohio they nicknamed the Big Ear, something truly wild happened. For a full 72 seconds, the telescope locked onto a signal so strong, so unusual, it was unlike anything anyone had ever seen. And just like that, it kicked off a cosmic detective story that's still going nearly 50 years later. So, a few days go by, and an astronomer named Jerry Ehemann is just sifting through the data printouts, these long sheets of computer paper. And then he sees it, a string of characters representing a signal that was just, well, off the charts, way, way stronger than the normal background noise. His reaction was so genuine, so spontaneous, it ended up giving the signal its name. He just circled the data and scribbled one word in the margin: wow. Now, what made this signal so incredible wasn't just its power. It was broadcasting at 1420 megahertz. Why does that matter? Well, that's the exact frequency of neutral hydrogen, which is the most common element in the entire universe. Some scientists have called this the universe's watering hole, a natural frequency you might use if you wanted to send a message. But here's the biggest mystery of all. After those 72 seconds, it was gone, vanished, and it has never, ever been heard from again. A signal like, wow, you can't help but ask the big question, right? Could it have been from, an intelligent source? Well, before we can even begin to go down that road, scientists need a really strict set of rules, a kind of test to figure out if we're hearing a genuine cosmic hello or just more of that cosmic static. And this, right here, is the central puzzle for anyone in the search for extraterrestrial intelligence, or SETI. I mean, when you're literally listening to the entire universe, how on earth do you filter out all the natural chaos to find one single deliberate message? What are you even listening for? Okay, so here's the fundamental difference. Think of it like this. Natural sources out there, like stars and pulsars, they're messy. They just blast their energy out across a huge range of frequencies. It's like the static you hear between stations on an old radio. But technology? Technology is efficient. An artificial signal would almost certainly be narrowband, focusing all its power onto one specific frequency so it can be heard clearly, just like your favorite radio station. So before anyone can even start to whisper the word aliens, a signal has to pass this really tough checklist. First, you've got to rule out every single known natural cause. That's a huge step. Then it has to be verifiable. Other telescopes, other teams have to see it too, just to prove it's not a glitch in your own equipment. And the real holy grail? A non-random pattern, something that just screams intelligence, like a sequence of prime numbers. The WOW signal, it hit some of these marks, which is why it's so tantalizing. But it failed that crucial test of verifiability. The WOW signal was a one-and-done kind of deal, a ghost. But what if the universe is sending us mysterious signals all the time, not as a single quiet whisper, but as a full-on storm of incredibly powerful bursts? Well, that brings us to one of the biggest puzzles in modern astronomy. Just try to wrap your head around that for a second. Take every single bit of energy our sun produces in one entire year, and then unleash it, all of it, in a flash that lasts for just 1,000th of a second. That is the absolutely mind-boggling power we are talking about here. Yet these things are called fast radio bursts, or FRBs for short. They are insanely bright, unbelievably brief flashes of radio light coming from galaxies billions of light years away. And for the longest time, we had absolutely no idea what was making them. Our understanding of FRBs has just exploded recently. The very first one was found totally by accident, just sitting in some old data back in 2007. For years, we figured they were all one-time cataclysmic events, like two stars colliding. But then in 2016, everything changed. We found one that repeated. This was huge. It meant whatever was making the burst had to survive. And just recently, this is incredible. With help from the James Webb Telescope, a burst was traced all the way back to a galaxy so far away, the signal had been traveling for 10 billion years. That's long before our own planet even existed. And this is where the plot really thickens. Some FRBs flash once, and then poof, they're gone. But others repeat. And some of those repeaters have this really weird, regular rhythm to them.
There's a famous one that goes through a cycle of activity every 16.35 days. Now, a pattern that regular is way too slow to be a star spinning. Something else has to be the clock.
Okay, so we've got our two big cosmic mysteries on the table, the lonely wow signal and this ongoing storm of fast radio bursts. It's time to put on our detective hats and take a look at the lineup of cosmic suspects for both.
So for the wow signal, that ETI hypothesis, it hangs around because of how clean and narrowband the signal was. But it's impossible to prove, since we never saw it again. Another idea, that it came from a comet's hydrogen cloud, has pretty much been dismissed. The math just doesn't work. Right now, the leading natural explanation is a really rare kind of astrophysical event. The idea is that maybe a flaring star's energy passed through a cloud of hydrogen gas and just lit it up, creating a super brief, super intense narrowband flash, a perfect but incredibly rare cosmic coincidence.
Now, for FRBs, the number one suspect is one of the most extreme, most bananas objects in the entire universe, a magnetar. Okay, so this isn't just a regular neutron star, which is already a city-sized object with the mass of the sun. No, a magnetar is a neutron star with a magnetic field so powerful it pretty much breaks physics as we know it. These are the cosmic engines we think are powerful enough to create FRBs. So how could it work? Well, the leading theory is something called a starquake. I mean, just imagine the unbelievable forces twisting and pulling on the surface of a magnetar. The idea is that when its crust cracks or shifts, it unleashes this colossal burst of magnetic energy that tears through space as a fast radio burst. This explains the insane power and, crucially, how the star can survive to burst another day.
Okay, so the starquake model is great for explaining random, repeating FRBs, but it doesn't really explain the periodic ones. Why would a magnetar have a quake on a precise 16-day schedule? That seems way too neat. That kind of long, regular timing suggests something else is going on, something outside the star itself. It points to an orbit. And that brings us to this really clever and elegant solution. The magnetar isn't alone. It's probably in a binary system, orbiting another star. The theory goes that the magnetar might be bursting all the time, but we can only actually see the flashes when its orbit takes it through a specific part of its companion's stellar wind, which acts like a cosmic magnifying glass or a lens. So that 16-day cycle, that's not how often it bursts, that's how long it takes to orbit its partner.
So we've lined up our suspects, we've got our theories. You might think we're getting close to solving this. But of course, a recent breakthrough in FRB research is forcing us to rethink basically everything we thought we knew about them, challenging the very idea of how we sort them. So if you just look at the raw data coming in from big surveys like the amazing CHIME telescope in Canada, it seems pretty cut and dried. Repeaters look incredibly rare. I mean, for every one repeating source we've found dozens that have only ever flashed once. So on the surface, it looks like there are two totally different kinds of FRBs. But here comes the twist. What if there isn't actually a difference? What if a non-repeater is just a repeater that's really, really quiet? One that has such a low burst rate that in our limited time watching the skies, we've only been lucky enough to catch it once. And this is exactly where the new thinking is heading, based on some really careful statistical analysis of all that CHIME data. The rate at which we're finding new non-repeaters is slowing down, which suggests we might be seeing the same ones over and over without realizing it. The new models are predicting that more than half and maybe all FRBs come from sources that can and do repeat. So what does this all mean? Well, it means we've been totally focused on the sources that shout, the ones that are really active and easy to find. But the universe might be absolutely packed with a huge population of sources that only whisper, maybe bursting just once a decade or even once a century. Our telescopes, like CHIME, are finally becoming sensitive enough and are watching the skies long enough that we're just now starting to hear them. This completely changes how we think about the high-energy universe. It suggests these extreme events are way more common than we ever dared to imagine. It just makes you wonder, doesn't it? As our technology gets better, as our ears get sharper, what other profound, universe-altering whispers are out there, just waiting for us to finally tune in and hear them?